Let us continue looking at definite integration, and we're going to continue using definite integration to find the area under a curve. Now, previously, what we did was this. We had x-axis, y-axis, then a straight line. We integrated from one point, call this A, lower boundary, to another point, B, and we found the area here, shaded area. Now, that was integral from A to B of a number. We use 1 dx, it could be any number. But of course, you could easily use any other method like the length by the height here. This would have been 1 up here. The length by the height, or the width by the height, to find the area, because it's a rectangle. Then in the other case, this was what we did. We integrated x dx. In that case, what you had was a situation like this. Let me just erase some of these things that I have here. The situation we had there was this. We had just a straight line, and you integrated from A to B and found this shaded area. The thing is, you could easily have done it otherwise. For example, you could cut this into two shapes, a triangle and a rectangle. Find the height of the rectangle, multiply by the width. Alright, from A to B, that's the area of the rectangle, and then the vertical height of a triangle by the width, and half. So the area of the triangle is half. If you call this the base, or this is the base, but call it the width, we already label it as width, W. Half the width times height, that would give you the area of the triangle. As for the rectangle, it is the width times the height, and you add them. So you could have done it otherwise without calculus, and it was accurate, right? You got an accurate value of the area whether you use calculus or not. But now we have another situation. Let's look at it. We want to find the integral of x squared dx. Now, the thing is this. From A to B. But just before we look at it further, let us put in some values here. Let's say from 0 to 1. Good. We want to integrate from 0 to 1 x squared dx. The thing is, you remember that if you have your x-axis and your y-axis, right, the graph of x squared is not a straight line. It's going to be a curve. It looks somewhat like this. And if you are going to integrate from 0 to 1, and let's say 1 is here, it means you have this area bounded by 0, 1, the curve, and the x-axis, or this part of the x-axis here, right? This is y equal x squared. The shaded area that you're going to find is this. Now, as I said, you can use calculus, but the thing is you have you don't have some other way of getting an accurate value of this area, right? You could try and estimate the value of this area using some other method, but I want an accurate area. You have to use calculus. Now, suppose, for example, let us look at GeoGebra, and we're going to be using it to plot our graph. The graph of y equals x squared. Let me look at our graph closer. We're going from 0 to 1. So let's zoom in. Zooming in. I want a wider view. So there we have it. Y equals x raised to the power of 2. Aha, there we have our curve. Let us kind of set up our curve. I want to see the name and the value. It is the equation, and make our curve thick. All right. Now we have our 0 here. We have our 1 here. The area that we're going to find is bounded by the line, the x equals 0, the line x equals 1, the curve y equals x squared, and this part of the x-axis, right? The area that we want to find is therefore, let me shade the area here, is this area under here. This is the area that we want, right? Let me make a little adjustment here. All right. So this shaded area is the area that we want. Suppose you're given this graph and you're asked to find the area under the curve accurately, not estimated. You're not going to count squares, right? You're not going to find the area by counting squares. You're going to get an accurate value. Then you're going to use calculus. What you would do is this now. You're going to integrate from 0 to 1 of x squared dx with respect to x. So the integral of x squared is x cubed divided by 3. Remember, you add 1 to the old power to get the new power, and you divide by the new power. You have your square brackets on the right square bracket, the right hand side of your right square bracket. You put your lower boundary at the bottom and your upper boundary at the top. Then you say you're going to have x cubed over 3 at the upper boundary minus x cubed over 3 at the lower boundary. You remember also, you don't bother to use the constant of integration because it will subtract itself anyway. So the upper boundary is 1, so let's get rid of this x cubed and put 1 cube. So it will be 1 cube divided by 3 minus the lower boundary is 0, so we get rid of this x cube and put 0 cube. So it's 0 cube over 3. So here 1 cube is 1 divided by 3 minus 0 cube is 0 over 3, which is 0. But You don't really need this. The answer here is 1/3. The answer is 1/3. All right? This is an accurate value for the area, the shaded area here. Perfectly accurate value. All right? So you have x squared from 0 to 1. You have x cubed over 3. Therefore, 1 cubed over 3 minus 0 cubed over 3. So this is 1/3. So you see that? Now, what we're going to do is make a little adjustment, but we're going to do that in the next video and then to find another area. So I will see you in the next video.